Good morning friends, and I am going to discuss you about the section of solids, and I already explained you the different types of solids in the projection of solids chapter. So now we are going for the projection of section of solids. So now what section is, if we cut any solid by any particular plane, so this is called the section of a particular solid. Okay, this is a cone and we are cutting this cone like this. Okay, this is a plane, we can only cut the solid by the plane. Okay, and we are cutting this particular cone like this. Okay, and throughout we are cutting this cone like this, and we just remove that part. So the plane which is cutting this particular cone, the plane which was cutting this particular cone is called cutting plane, and when it is removed, the plane which is obtained after removing the cutting part, so this is called the sectional plane. Okay, so we know that this particular cone is resting on HP. This is the HP and this is the VP. Just you can imagine, because you have already studied about the projections. So this is our HP and this is our VP, and this is resting, this cone is resting on HP such that its axis, where the axis exists in this cone, this is the apex or vertex, and this is the base. The line, the hidden line joining this center of this circle or center of this base and apex is called the axis of that particular cone. So this is a cone resting on HP on its base, and when it is resting on its base, what is the position of axis? The position is perpendicular to HP and parallel to VP. Okay, that's all. Now we are cutting this cone by a plane. This is the plane. Okay, I have already explained that solid can be cut only by the plane. Okay, and we are cutting this cone by a plane which is inclined to HP and perpendicular to VP. You are having very good concepts of plane. This is the inclined, this is the plane which is inclined to HP and perpendicular to VP. It is cutting by a plane inclined to HP and perpendicular to VP. So throughout we are cutting this particular cone, and the cutting part will remove, and this obtained part is our sectional plane. Okay, so this is the solid of revolution, cone. I have already explained you there are three types of solids: prism, pyramid, solids of revolution, and polyhedra. Four types of solids are there. Okay, and this is our cube. This is our cube. Basically, this is the example of polyhedra. This is our pyramid. This is our pyramid. Okay, and prism, you know already. You can take the example of this duster. This is a square prism or cuboid. This is also called cuboid, and this can be also known as, because there is a square. Okay, this is called the square prism. Okay, so I am going to discuss you about the different sections of that solids, different types of solids. So I am taking an example of this simple duster. Okay, simple duster. So just we have to locate that duster in respect of horizontal plane or vertical plane or reference planes. Okay, so we are locating this duster which is resting on HP on its base. This duster is, you have already done lot of problems on this particular square prism and square pyramid, and many problems you have already done in projection of solids. So I am taking an example that this particular square prism is resting on HP on its base. Okay, this is resting on HP on its base. Now in this condition, its axis is perpendicular to HP and parallel to VP. Now a plane which is inclined 45 degree to HP, a plane which is a cutting plane which is inclined 45 degree to HP, cuts this particular square prism and bisects its axis. And bisects its axis means the cutting plane cuts from the middle part of this square prism. This cutting plane cutting this square prism by the middle, and this cutting plane is inclined 45 degree to HP and perpendicular to VP. And when it cuts, just imagine, then this part you can remove. This part, after cutting, this part you can remove, and you can easily just construct the sectional plane shape. Okay, now just imagine when we cut this by a cutting plane and this part we do, what we can see in the top view. What we can see in the top view after removing this part, we can only able to see a square same to this base on the top view. Okay, and what we can see in the front view, there is a this type of shape. I mean, this cuts because this is inclined, this cuts, and this part. Okay, okay, I can also, if you can imagine, this part, and this is the our remaining portion, truncated part. Okay, and the top view which we are able to see in the top view, that is not the true shape of the sectional plane. Okay, that will not the true shape of the sectional plane. After removing this, because it's cut by this particular plane, so this particular plane is already inclined. This particular plane was already inclined. So when we see in the top view, we are not able to see the true shape of that particular sectional plane. Okay, so what is the true shape of the sectional plane? Just imagine, that is not a square, that is a rectangle. Okay, now one thing more I just want to discuss you. If this plane was not inclined, if this plane is parallel to HP, or in recent condition the plane was inclined to HP, now the plane was parallel to HP. So when we cut this particular prism by a plane which is parallel to HP, then what happened? After removing this, we are able to see the square. In the inclined plane we are able to see the square, and in the parallel cutting plane we are able to see the square after removing. But in the top view, okay, and when the plane was inclined, that was rectangle, and when the plane was parallel to HP, that was not rectangle, that was square only. Okay, when this is, because whatever shape we are able to see, the same shape we are able to see here. Okay, so this is our main funda of section of solids. Now I am just going to draw. So our condition was that this square prism is of base side 30 mm and axis length 60 mm is resting on HP on one of its bases such that one of its base side is parallel to VP. So just draw that condition for the square prism. Okay, this is the XY line, and in the top view we are able to see the square. We are able to see the square only. Okay, here we can give the naming A1, B2, C3, and this is D4. So A1, B2, D3 and C3 and D4. So all of you know that A, B, C, D are the namings of the top base because they are known in the bracket, and 1, 2, 3, 4 are the namings of the bottom base because they are in the brackets. And in the front view, this is our front view of a square prism. Now here the naming is A dash bracket में D dash, then B dash bracket में C dash, this is 1 dash bracket में 4 dash, and this is 2 dash bracket में 3 dash. This is our namings of the front view. This is all the part of the pane, so you don't have to confuse what is this. Okay, this is the part of the So this is basically our top view of front view. Now we have to do our sections. Now the remaining question is, if we cut that particular prism, if we cut that square prism by a cutting plane which is parallel to HP and perpendicular to VP and bisect the axis. So this is the axis where we can draw the axis. This is the center and this is the chain dotted axis. This is the axis. So it bisects means the half of this axis is, means this is the 60 and this is the point here 30 and this is the center C. If we cut this prism by a cutting plane which is parallel to HP and bisect the axis, means like this, we are cutting like this, we are cutting this square prism like this at the half of the axis. Okay, so we have to draw a cutting plane first. So always remember that cutting plane always shown by the double chain dotted line. Cutting plane always showed by the double chain dotted line. Means one line, then one dot at 1 mm, then another dot at 1 mm, then one line at 1 mm, then a simple line of 2 mm, then one dot, second dot, then a line of 2 mm. So this is called a double chain dotted line. This is the 2 mm, 1 mm gap, one dot, 1 mm gap, second dot, 1 mm gap, then 2 mm line, then 1 mm, 1 mm, 1 mm till 2 mm. This is the double chain dotted line. So we are just showing the double chain dotted line for the cutting plane. Okay, so I am just showing this by the different color cutting plane by this color only. Okay, so this is our cutting plane. Okay, just naming this cutting plane. Always remember one thing, that this cutting plane cuts 4 of its longer sides. 4 of its longer side. 1, 2nd, 3rd, and this is the 4th. 4th of its longer side. So here, this is P for A and 1. You can see the P. You can give the P naming. And for D and 4, you can give the Q naming because Q is hidden. For B and 2, you can see the R naming, and for C and 3, you can give the S naming. S is also hidden. This is our cutting plane line. Now, I just want to ask you that after cutting, this portion will get removed. What we are able to see in the top view? What we are able to see in the top view? We are able to see only the shape, which is the shape of its base, because the plane is parallel to HP. Means whatever shape we are currently, we can watch in the top view. After cutting this plane, after cutting by a plane which is parallel to HP and removing the same shape, we are able to see only. So after removing this, we can see this square only in the top view when the plane is parallel to HP. So here, when we show the sectional plane, always remember the sectional plane, that part of the section is shown by the line which is inclined 45 degree to XY line, which is inclined 45 degree means you put your drafter or a roller scale 45 degree to the XY line, and 1 mm or 2 mm gap behind the two lines, and this shows the sectional plane. This particular part shows the sectional plane which we are able to see in the top. Thank you so much, and the inclined plane I am going to discuss.